we're going to start talking about how atoms can be different between different elements and even in the same element. So we're going to pick up here with just looking at the subatomic particles and some of their properties. So for example, the electron, we use the symbol E with a negative sign to represent electrons when we're writing. So you can use that in your notes instead of writing out the whole word. The mass of an electron is 9.11 times 10 to the negative 28th power. So it's super, super tiny. Um, and the charge, of course, is a -1 charge. Right, right. That's fun. I don't see my, oh, there it is. Right here, -1 charge. Okay, and of course the location is in this electron cloud. Okay, and then you got your protons. Those are represented by a lowercase p, and it's 1.675 times 10 to the -24th power. So still tiny, but not as tiny as an electron. It has a +1 charge, and it lives in the nucleus. A neutron is represented by a lowercase n. It has the same mass as a proton, but it has no charge, which is why it was so hard to find, and it was the last particle that we found. And of course, that also lives in the nucleus. Okay. All right, so we're going to break down what an element card on the periodic table has on it. Okay. So we start with uh, the element symbol. Okay. Okay, so that's usually a single letter. Sometimes it's 2 letters. Never more than 2 letters unless it's an unnamed element. But right now we have all named elements on the periodic table. So that should be right about in the middle of a card. But sometimes you'll see it in the upper right-hand corner. Okay. Your atomic number. This is usually in the upper left hand or in the upper center of the card. And this represents the number of protons in a element. Also, it corresponds to its place in the periodic table if you start at the left and go right and then move down each row as you go. Underneath of the element symbol, we'll have the element name. And so this is really what lets you connect the symbol to the regular word in English. So every card should have the element name on it, and it's usually in the middle, and sometimes it's across the very bottom, but usually it's above this number. And then the last thing on the element cards for just a typical periodic table is the atomic mass. And so this is a number, and it usually has a decimal in it. Okay, and so that number represents the average mass of the element and all of the versions of that element. Okay, and it's weighted, and we're going to learn how to do that, but that's going to be in a different video. Okay, right. Okay, so element cards tell you a lot about an atom, even with just those 4 things on them. For example, an atom's atomic number is equal to the number of protons in every single atom of that element. If an atom has 1 proton, it is always going to be hydrogen. If it has 6 protons, it will always be carbon. The protons determine what element you have. In every neutral atom, that number of protons shown by your atomic number is going to be equal to the number of electrons as well. So just with one single number, you know the number of protons and the number of electrons for an atom, for an element. The atomic mass at the bottom is approximately or about the sum of protons and neutrons in an atom. Now with this, you do have to round it to the nearest whole number because, like I said, there are different versions of each element that have different numbers of neutrons, which we're going to talk about, and they throw that number off a little bit. Okay. So just from those two numbers, you can find out about 4 things about an element. Okay. And again, the atomic number also tells you where to find that element on the periodic table. So you can think of it as like directions to finding it. All right. So I want you to pause the video, take out your periodic table, pick any element, and try to figure out the number of protons, electrons, and neutrons. So I'm going to let you take a second and just pause the video. Okay, now that you've done that, um, raise your hand and ask me to come around and check it. You can write it anywhere in the margins or whatever. Okay, so the last two items on the card, the element symbol and the name, will help you read and write chemical formulas later on. It is also useful if you need to shorten your notes or labs because you can write the symbols and the formulas of compounds instead of writing the whole name of an element or the whole name of a compound. So if you're really good with your periodic table, you don't have to write as much in your notes because you can just write a symbol instead of writing a whole word or a set of words. Okay. So let's take a look at mass numbers. So mass number is not on the typical periodic table, but this is something that you can calculate if you have um, the number of neutrons and protons in an atom. Okay, so atoms have mass numbers. They represent the calculated mass in atomic mass units. They're shortened to AMUs, and you'll see that off and on. AMUs and grams are interchangeable when you're talking about like chemical formulas and amounts of atoms. And that's for a specific atom of an element. So if I tell you an atom of carbon has 6 protons and 6 neutrons, you can calculate the mass number is equal to 12 AMU. Okay, so the mass number will always equal the number of protons and neutrons. Woo. Yep. Or it'll equal the atomic number plus the neutrons. Okay, if you have either protons and neutrons or atomic number and number of neutrons, you can calculate that mass number. Okay, now that mass number is unique to that particular version of that element. So there are standard mass numbers and then there are non-standard mass numbers. Okay, so I want you to stop and complete the practice exercise using atomic numbers in your notes and then raise your hand for me to check it.